Good morning, and thank you for joining our panel for this very important topic. One housekeeping note, this session has been approved for continuing education. If you would like to receive documentation of your attendance, please make sure to have your badge scanned at the close of the session. If you are a current AFCEA member and have purchased a continuing education pass, AFCEA will email you documentation of your attendance to maintain your continuing education records within 4 weeks. If you are neither an AFCEA member nor a holder of the CE Pass, you may get your badge scanned and join or renew at the AFCEA booth. I would like to welcome you to our panel. I'm Lisa Smiley from Walker & Associates. I've been in the telecom and ICT industry for almost 30 years. I've served in many capacities within Walker. Currently, I'm responsible for the strategic growth initiatives regarding our new manufacturing development. I'm committed to our business to ensure that we have OEM partners that meet our stringent corporate requirements of supply chain risk management for both Walker and our customers in order to provide stability, control, and integration of these manufacturers and reinforcing our business practices. Today, we will begin with one of our panelists, Tim Brown from Network Utility Force. He'll be discussing security threats and risk in our supply chain, plus tools available to combat security risks. Once he concludes, then we'll hear from our other three panelists who'll be discussing the National Cybersecurity Strategies vision, how it applies to them, their response, what that will be, and the impacts that they envision. We have two panelists from industry and one from government. I'll introduce each of them before they begin. Following that, we'll have a question and answer time. I'll begin with a question for the panel, and then we'll open the floor for questions from the audience. The September 2018 Cyber Security Strategy is changing our national vision regarding supply chain management due to the security risks uncovered over the last few years. Before we begin, I wanted to point out the 4 pillars mentioned in this strategy. Pillar 1, protect the American people, the homeland, and the American way of life. The objective is to manage cybersecurity risk to increase the security and resilience of the nation's information and information systems. Pillar 2, promote American prosperity. The objective is to preserve the U.S. influence and technological ecosystem and the development of cyberspace as an open engine of economic growth, innovation, and efficiency. Pillar 3 is to preserve peace through strength. The objective is to identify, counter, disrupt, degrade, and detour behavior in cyberspace that is destabilizing and contrary to our national interests while preserving the United States overmatch in and through cyberspace. The fourth and last pillar is to advance American influence. The objective is to preserve the long-term openness, interoperability, security, and reliability of our Internet, which supports and is reinforced by the United States interests. While all these pillars are important, and the Department of Defense plays a role in each one, pillars 2 through 4 are extremely dependent upon Pillar 1. Pillar 1 consists of securing federal networks and information, securing critical infrastructure, and combating cybercrime and improving incident reporting, all of which are interdependent. Supply chain risk management plays a role in all components of Pillar 1. Our information security supply chain is currently under attack and has been for some time. Per the 2018 Mitre study, delivered Uncompromised, a strategy of supply chain security and resilience in response to a changing character of war. Nation-state adversaries have exploited cyber and supply chain vulnerabilities critical to U.S. security for hostile purposes. These include exfiltration of valuable technical data in the form of industrial espionage, attacks upon control systems used for critical infrastructure, manufacturing, and weapon systems. Corruption of quality and assurance across the broad range of products and categories, and the manipulation of software to achieve unauthorized access to connected systems and to degrade the integrity of the system operation. First, I would like to introduce Tim Brown as our first speaker. Tim is the Director, Security and Virtualization Network Utility Force. He's been involved in networking engineering and operations since 1995, originally serving as a support engineer in a small ISP in the Midwest. His experience since then has included a variety of technical and managerial roles at companies that involved digital music distribution, OEMs such as Cisco Systems, a variety of VARs and distributors, hosting and internet service providers, and consulting. During his tenure at Cisco, Tim spoke and managed tracks for Cisco Live, and he was involved in pre-sales engineering, consultative support, network and security architecture for the top 10 global telecoms. His consulting experience includes several large engagements, including application delivery architecture in one of the top 10 U.S. airlines, security engineering and architecture for large institutional investors, work in several major retail banks, both private and public, and handling data center consolidations for 3 enterprise customers in oil and gas, finance, healthcare, and the sole point of contact for network and security virtualization. Tim?
Thanks, Lisa. Appreciate the introduction. Good morning, everybody. I think, as everybody knows, supply chain security is a pretty critical topic. As a country, we're very technologically dependent, and because much of our supply chain is very heavily globalized, there are a lot of risks that have to be mitigated. I think if you care about the American way of life, you have to be somewhat aware of supply chain security because it affects everything. It affects the power at your home. It affects what you do every day on the internet. It affects your banking. It affects everything. There are several initiatives focusing on supply chain security on the world stage. We're not going to be able to talk about all of them today, but I'll give a summary at the end of the talk. Not all of them are focused on technology, but they don't always have to be to help mitigate the risks. Much of our supply chain risk is actually not necessarily in the technology space. It's in how we manage the chain of custody of items from source to destination. In my opinion, the biggest challenge in supply chain is really the scope of the problem. It's very, very hard for private enterprise and federal agencies to conduct proper supply chain security activities, and we're going to talk about why that is. But in general, if you really want to be focused on securing supply chain, it has to be something that if you're an end user, you are spending a ton of money trying to secure those things. So what I'm really going to talk about today is a collaborative approach that not only looks at the end user, but also looks at all the elements of the chain from start to finish. In general, supply chain risks come from 3 categories. Malfunctions, such as intentional sabotage, faulty design, or engineering leading to the failure of a component at a critical moment before things leave the factory. So that's somebody deliberately putting in something in a chip to cause it to malfunction at a critical moment, and those can be extremely complex vulnerabilities to solve, right? It can happen at a very specific time. It can happen when combat systems come operational, for instance, when the person's actually engaged in firing live munitions and things like that. So it's important to be aware that malfunctions are only one of the several risks that we have in supply chain. The second kind of category of risks that I would characterize are data exfiltration risks. And this is a situation where you've gone to a great degree of effort to have secure infrastructure. You've gone to a great degree of effort in securing every element of how data gets from point A to point B, but we still rely on things like firewalls, intrusion detection, and everything else. And because we rely on those things, we can't always trust that they won't potentially exfiltrate data on prompting from a foreign adversary or a commercial adversary. So those backdoor capabilities can be engineered into anything from connectors to chips. I have a proof of concept of a USB cable that does it. We've seen people put things so small like resistors on boards, and those capabilities can be in there. So it's a pretty scary problem. The data exfiltration risk can be tied into the malfunctions piece above, but it's really more about leaking confidential data than anything else or allowing remote network compromise. Another problem that we have in the supply chain is interception in transit. So that's critical technology that's falling in enemy hands to be studied or modified even after rigorous testing. So if you are shipping a product from the U.S., from 2 destinations in the U.S., It is not out of the realm of possibility, if you don't control the entire shipping of that product, for an item to be captured, temporarily tampered with, or replaced with another item, and then either being studied or modified, usually after all of the effort of getting the item into the supply chain happens. So security professionals will be familiar with the confidentiality, integrity, and availability triad. And that is a good way to think about supply chain risks, because that's kind of the same things as I just mentioned. So what does a typical supply chain look like? I think everybody's probably familiar with this, at least you've thought about it at a high level. But it's raw materials, so whether that's rare earth metals, silicon, whatever, the chemical and mineral components that we have in our technologies. And those raw materials go to kind of the stage one component manufacturers, right? So people that manufacture chips, people that manufacture electrical components, et cetera. There are risks in that chain, research and development risks, manufacturing and transport risks. They're all present at the start of the chain before we get anywhere else. Then once those stage one component manufacturers are building their chips and everything, they're shipping it to packagers or stage two component manufacturers. And these are people that are putting those chips on boards, putting those boards in pieces of equipment, et cetera. Once the component manufacturers are all done, then it will go to the final manufacturer for development of the product and deployment of the product. And the final manufacturer also has a pretty awesome responsibility there, because they have to go back and look at the entire supply chain. So if I work for an OEM, I not only have to be concerned about my typical supply chain risk, which is did my rare earth metals, did the cost increase? Do I have to deal with tariffs? Do I have to deal with anything else? But I also have to worry about all of the risks inherent in the chain before those chips and boards even get to me. So that's something that people have to keep in mind. Once we get beyond the component manufacturers, then it would go to the final manufacturers. It would go into a wholesaler inventory, so something like a distributor or a reseller. And then there's prep and transport and ongoing operations. Once the wholesaler has it, there may be another reseller in the chain that would have to take the product, and then it would go into the customer inventory. So those are all elements where there's some risk of the product getting into the wrong hands, or the product being modified, or anything along those lines. So if you think about having to manage those global risks, it's really, I would say, partially about chain of custody and partially about making sure that the product is what you said it was. Manufacturers sometimes don't even know that equipment that is counterfeited is entering into the product chain. So we've seen people, if you go look at some of the research from the last year, there are people that have batteries, boards, chips, etc. They look functionally similar to the device that would normally be purchased to an official device, a non-counterfeited device, but they are very different inside. And it takes a very trained set of individuals and a very deep and monetarily expensive chain of technologies to be able to figure that out. So how do we protect our supply chains? I think the number one element that people can take to protect their supply chain is to pick a good vendor. Some of these risks that you have in the supply chain, I think, are reduced by selecting the right vendors. And what you're looking for in a vendor is a responsible partner for your business. So if you're picking a vendor that is not necessarily based in the U.S. or not headquartered in the U.S., you are not necessarily going to get the same level of interest from that vendor of protecting U.S.-based technologies than if that vendor were in a place such as China or some other foreign country. It's still hard to deal with the risks even if you pick a responsible vendor, but if you have somebody at the top of that vendor, the owners, the board, et cetera, who are all responsible actors and can push the attitude down the supply chain, it really helps. You're looking for mutual self-interest when you're looking at those kind of things. Separate from the vendors, I think that there's a fairly large risk there in the fact that there are so many people involved in today's R&D efforts and product development. There's a lot of entry points for bad actors. Not all vendors have a research and development team that is not made up of contractors, or at least not partially constituted of contractors. And those contractors may not necessarily be subject to the same degree of background checks as a normal actor would be. So I think it's important to keep that in mind. The background checking is paramount, but it doesn't solve all problems because not every engineer at every company, and not every R&D person at every company is going to get a full scope SSBI or anything like that. So those are all problems that we kind of have to think about and solve. Not all of the vendors, some of the vendors up here today do, but not all of the vendors have a good program for validation of the research and development efforts. I think code and design quality assurance is not an easy problem to solve either. So if you have somebody involved in a product, you can't necessarily say that they're building that product for very high assurance environments, combat environments, things like that, or critical infrastructure protection. Chip vulnerabilities in general require a very extensive amount of hardware to validate. So you might think that manufacturers can just take an x-ray of a board and see all the vulnerabilities. That's not necessarily true. It costs many millions of dollars for some of the machines that it takes to really identify that you've got a counterfeit or a counterfeit chip or a counterfeit board. And miniaturization of those components simultaneously makes attacks more easy and more difficult. And what I mean by that is it's harder to manufacture components that are designed to cause a problem, but it's also simultaneously harder to spot those components that are designed to cause a problem. Because if you're looking at the 10 nanometer range or below, which is what some of these chips are manufactured to today, it's extremely difficult to really understand that logic and to be able to assess that for yourself, which is why having a good vendor partner is important there. There are also risks during the manufacturing phase, right? So there's a lack of verification of the design after manufacturing, loading, et cetera, is complete. You know, once the product is manufactured, you may not do the same verification that you would do in the R&D phase. The logistics management risks, I think, are common across all of the supply chain security initiatives. So that's basically making sure that you've got a chain of custody of the product from the raw material all the way in. And vendors that can assure you of that entire chain are probably some of the more secure vendors that are out there because it proves they've been thinking about the risks. In order to manage that chain of custody, and we'll have some of our partners up here today talk about that, you know, it's not so easy to just put some security tape on a box, right? There are a lot of things that can happen to a product from the time it leaves the factory or the final manufacturer to the end user. So just keep that in mind. Luckily for us, the logistics management piece is mostly a solved problem. The solution set's very easy to understand. You track the trucks, you track the people, you track the product, and those are all fairly easy problems to solve. And you'll know when there's an absence of data. You'll know when you don't see a GPS ping from a truck. So that's important to kind of keep in mind. Not all of the solutions for track and trace or container security are audited or designed in such a way that they couldn't be imitated, though. So even if you have a vendor that says, yeah, we do track and trace of all of our products, we can show you the chain of custody from start to finish, that doesn't necessarily mean that the vendors had those professionally audited by a security firm. So that's important to keep in mind. Once gear arrives to the facility, the samples or the complete inventory really should be tested. The validation can involve a lot of things depending on the nature of the hardware or software. It's not enough to make sure that it says it does what it's going to do. So in other words, when we go ahead and we put routers in places, we test those pieces of equipment for functionality. We test to make sure they're doing what they're expected to do. But it's not always easy to make sure that they're doing what they're expected to do all of the time. Because that test is a fairly short window. It might be 4 hours, it might be 8 hours. So if you're really going to go through and take verification seriously, you have to test in adversarial scenarios, like red team scenarios, as well as what you would normally test in terms of functionality scenarios. So that's important to keep in mind. Once the product's in your shop and it's installed and everything else, you also have to be aware of update security, right? Because all these products are software updatable in a lot of cases. So the vendor is shipping you code. That code has to be retested as soon as things are done. And process validation, I think, is important across all elements. It's not enough to take people's word that they do these things, but it's important that they actually do them. So there's several initiatives. We can't really go into all of the specific initiatives today, but the one thing I would have everybody keep in mind is that there's DHS efforts, there's DISA efforts, there's efforts at some federal agencies that are independent of those efforts. I think from the point of view of the vendor or the point of view of the reseller, there are so many different supply chain security initiatives that it's hard to ensure complete competence with all of those initiatives. So the one comment I would make is that if you're in an organization and you're responsible for developing a supply chain initiative, it's very important, if you really want to rely on the vendor and the reseller and the distributor for support, that you're going through the process of helping them comply, helping them understand what's needed, and trying to build parallel capabilities across these initiatives so that if I satisfy one, I can potentially satisfy all of them. I think that's pretty much it for the intro to the discussion, Lisa, if we want to pass it on to other presenters.
Yes, thank you very much, Tim. Now I'd like to introduce Brad Minnis. He is the Senior Director of Environmental, Health, Safety, and Security for Juniper Networks, Inc., based out of Sunnyvale, California. He is responsible for strategic design, implementation, and management of the company's security, safety, environment, crisis management, and business continuity functions. He also leads the company's efforts in corporate citizenship and sustainability, and he manages the corporation's government-related security programs. Mr. Minnis has over 30 years of experience in the Silicon Valley. He's also served 10 years in the U.S. Navy. He also has co-written several publications on software integrity assurance and supply chain security with organizations such as SafeCode. He's also a certified as a protection professional. Brad?
Good morning, and thanks for coming. Supply chain security and product integrity is not new for technology companies. I did my first counterfeit investigation in 1988 involving diodes that were worth a half a cent each, but were being, scrap was being mass produced and resold into the marketplace. I spent many years prior to joining Juniper doing counterfeit investigations at another networking company that has since been acquired. And I think when I joined Juniper, Juniper was founded in 1996 on the premise that we solved the hardest problems in networking. We brought a new philosophy at that time to the company when we had one product, and that was the idea of brand integrity versus brand protection. I set up a brand protection unit back in the 1990s to deal with issues of counterfeiting and gray marketing. Really learned a lot about what not to do that allows those things to occur. And so when I came to Juniper, we implemented a program called our Brand Integrity Program, which really looks to protecting the product at every phase of the product life cycle, all the way from concept and feasibility, about understanding who the customers were for that product, what are their security issues, and how do we prevent those kinds of things from happening. So we kind of take a holistic view across the entire product life cycle about understanding what the threat landscape is, and then taking steps to eliminate or prevent those threats from occurring. We provide critical infrastructure to many government organizations, most of the major telecoms around the world, a lot of the social networking companies, and so the security of our products is paramount. We've been the target of nation states who try to infiltrate our products, both from the hardware perspective and the software perspective. Think back to the Edward Snowden days and the WikiLeaks releases that implied that certain government agencies were intercepting shipments of our products going to particular customers in order to perform some sort of a modification to the software or the BIOS code, which would create a vulnerability that could be exploited later. So we take this stuff very seriously, and we've been doing this for a very long time. Our program is really informed by numerous standards. As Tim mentioned, there are a number of initiatives across the government, both in the U.S. and overseas, trying to manage all of the requirements that are coming out of these organizations obviously is very difficult. But again, it's something that we've focused on for a very long time. I think one of the hallmarks of our program is that we establish long-time trusted relationships with our suppliers, our manufacturing partners, as well as our component suppliers, really looking at what is the ability of a third party to impact the activities that go on in that supply chain. So how could somebody influence or attack our products? And really understanding where the threat vectors are that apply to our products in particular. Now, if you make servers, you have a whole set of issues that apply to servers. If you make routers, there are a whole different set of issues that apply to routers. So it's really about understanding how our products work, where there might be vulnerabilities in the process, and then taking steps to eliminate those vulnerabilities. Much of the time it's about automation. So if you think about an electronics manufacturing line, the people that work on that line really have very little touch to the product. Most of the individuals that work on our production lines are there to keep the equipment running. Most of our processes for software download and component installation and programming BIOS code onto chips is all automated to take away the human element and eliminate the possibility that somebody could actually interfere with the code that goes onto a certain device or with the manufacturing of a certain product. But again, you have to be able to trust your suppliers, and you have to pick the right suppliers. One area that companies get into trouble with is when they outsource manufacturing, they outsource the entire program to the manufacturer, including procurement of components that go onto those products, as well as the security of the production line. What Juniper has done is we select all of our suppliers and vet them specifically, all of our component suppliers, so the manufacturing partners have no ability to go outside of our approved vendor list and source components that may cost less. They may source components from the gray market, which incidentally are also the same channels which counterfeit products move in. And then it's about how we deliver the products to our customers. We have an authorized reseller and distribution channel that we vet very carefully, and we place a lot of requirements on them for how they handle and treat our products. One of the other things Tim mentioned is the chain of custody issue from a manufacturer to an end user. In the typical distribution channel, when a product leaves our factory, most of the time the customer owns the shipping between our factory and the end user location. In many cases, people tend to choose the lowest cost provider for some of those services. So if you look at a shipment that may leave California and come to the East Coast, it may go on several different trucks, sit in 4 different warehouses on the way for unlimited periods of time in order to achieve the lowest cost mechanism to deliver that freight. So we've got to strengthen those delivery mechanisms and reduce the amount of touch that people have on that product. So I think I'm about out of time. So at the end of the day, it's really about the provenance of the goods, chain of custody, ownership of the components, and validating that those components have trust before you ship a product. The other thing is to employ technology to prevent the issues like counterfeiting and gray marketing. And so, Juniper has invested a lot of time on things like TPMs and DevID and trusted protection modules, also about secure BIOS development. And finally, most of our products have numerous pieces of open source software in them. So it's really about how do we vet that software before it goes into our products, looking at any vulnerabilities that might present themselves before we deliver the products to our customers. So ultimately, it's really about a holistic view of the threats to the product from the very conception of the product all the way through the end of the life of that product, and how we manage the threats and employ the best practices to ensure that our products do have integrity.
All right. Thank you, Brad.
Okay.
Now I'd like to introduce Jody Schatz with SafeNet AT. She's the Chief Product Officer. She's responsible for SafeNet AT's product management and engineering efforts in support of delivering data protection solutions to the U.S. federal market. She's also responsible for the strategic planning of the company and taking SafeNet AT's products to the next level. Jody?
Thanks, Lisa. So just like any aspect of security within a company, it's a shift in mindset. Typically, we're thinking one component or one area within a supply chain thought process. And it needs to start from the top down. So just like the U.S. government is pushing out a number of mandates and policies and all of the different policies that Tim had noted, industry needs to follow suit as well. And something we need to remember is that compliance does not necessarily equal security. So security needs to be woven through all aspects of our business in general. And supply chain is certainly no exception. So Tim did a great job of outlining the various phases of kind of a product development life cycle. And I'm going to start early on, focusing more on the design and development and offering up some what I see as best practices and certainly some things that we're trying to do within SafeNet AT as well. So the first one is that the supply chain threat, when you typically think about it, you're associating it with manufacturing. We've had a lot of focus on manufacturing, hardware, and suppliers and dealing with the kind of end game and the delivery. However, it's really a threat that starts from the very beginning with the concept of a product. And so the first item is really making sure you're following a very rigid product development life cycle. And Brad kind of alluded to this a bit too. And this impacts both hardware and software. So specifically on the software side, though, over the past several years, there's been the concept of what's called DevOps. And this is integrating and collaborating between the development teams and the operation teams to really bring together a product to market in a more efficient way. In the most recent years, it's been evolving into what's now DevSecOps. So this is where you're now making security an integral part of what the development and the operations teams are doing. And in doing this, one component from a software perspective would likely be implementing what's called a CI/CD pipeline. So this would be a continuous integration, continuous deployment pipeline. And this is something that is essentially developed for engineers that are working in an agile manner, that want to make quicker changes, less changes, but on a more rapid basis and be able to bring them to market in a secure way. So there's a number of security checks that can be built in an automated way very early in the process, focusing mainly on the build process, the packaging, and the testing front. So some examples would be static analysis on the actual code. Obviously, if we're pulling in open source, this can be run on that as well. And this would be checking the structure of the code, but without having to execute it. You can also check for vulnerability scanning and do this in an automated way to see if there's any known CVEs that you're being pulled into your product early on. Signing of your images is crucial because this is going to ensure that once your product is delivered to the end user and customer, that they can trust where it came from and know that it was not manipulated. And then with the recent push in the software world of using containers, there's a lot of security checks that can be done on how you're using containers. I think just last week, Cisco released an announcement that since 2015, Alpine Linux Docker has been shipping images that have default credentials with null passwords for their root users. This is something that should be checked in, built into a scripting process that goes into your pipeline along with a whole host of other security checks to make sure that from the very beginning you're building in integrity and checking for security from the beginning. So the second area would be for a company, recommendation is to establish what could be called a security working group or designate a security champion. So this would be either an individual or a team of folks that are security-minded, really with that security mindset first for their company. And they're responsible for any new product initiatives in the company, making sure that there's cross-functional awareness from the very beginning across the company of making sure that security is built into that process. So when you're talking about from an operations perspective, from marketing and how it's going to be propagated, from an anonymity perspective, and certainly from the development side. So it's going to check a number of things. First of all, on the development side, you may decide, what is going to be the risk attack area? Can we reduce the attack surface? Are we going to be building in USB ports or Wi-Fi or antenna or cameras and things of that nature into our product that are going to have exposures to vulnerabilities down the road? And these are some of the checks that you want to build in. How are we going to deploy the product? Are we going to make sure that we're defaulting to a secure set of default configurations and settings? And then on the operations side, are we looking at going with onshore or offshore vendors? And there's a whole host of considerations regardless of which approach you choose. Physical security is like building in tamper detection and zeroization capabilities. And then the list can go on and on. What are the roles and limited access and least amount of privileges that you're giving? What is the key hierarchy? How are you protecting your data and the secure elements of your product? So building all of these in from the beginning and having a security working group who is really reiterating those checks and balances from the beginning of the process is very important to push on through a secure product out to market. The third area is making sure that your company has an insider threat policy, and this spans beyond just design and development. And this is obviously the first focus is making sure you're training your employees and any associates that you may deal with, even it may be contract manufacturers, to make sure they understand what should they be on the lookout for and what are their obligations in the event that they identify something. So one thing to note is that typically when you think of insider threat, you're thinking, okay, I need to be aware of, is there suspicious activity that's going on? However, something to consider is that study after study shows that unintentional breaches are caused by general ignorance or carelessness, and they are far more outweighing than those malicious attacks. So for example, you may be the most loyal employee in your company, but if you open up a spear phishing email and provide your network logon, you may have now done a bit more damage to your company than even a malicious attacker would have done. So having that full awareness. Then there's also, on the insider threat perspective, the IT administration side, which is focused on strong password protection and policies, implementing logging and monitoring and auditing of all employee activity to identify if there's unusual behavior, and implementing secure backup processes. So if something is identified within the company and it's brought to light, there's a trail and traceability that you can go back and track down. And then the last area within the design and development is really around technology import. And I think Veracode said that of the majority of the software applications in the world today, about 75% is open source for those applications, for the majority of them in the world. So that's a lot of unknown technology you're pulling into your product. So when we're talking about technology import, it's applicable to both hardware and software. Most cases, customers and vendors are going to be using some third-party something. Whether it's a hardware component or a chip they're building into their product, or just a port or an Ethernet cable or whatever it may be, and certainly open source is another area to consider. So a couple phases that go from this technology import review process. It's really a risk assessment to make sure you understand what this technology component is, that you feel comfortable bringing it into your product and then releasing it as your product in the market. So first you want to check what is the origin of the code. And just to be clear, when we say it's we found an onshore supplier, that doesn't necessarily negate the insider threat potential. There are still challenges on U.S. soil, so it may reduce them, but we still have to keep that in mind. Understanding the origin, where it came from, will also help determine what the level of maturity is for that particular piece of technology. With hardware, you may go to the supplier and want to vet out the supplier, collect whatever schematics, layout, design documents that you can possibly get so that you really are understanding the design itself for this particular piece of technology. On the open source side, you want to get the end user license agreement, find out who's owning it, where it was developed, where it came from, and run it through all the same things that you would do your homegrown software. So the static analysis tools, the vulnerability scans, and things of that nature, basically to make sure that you are comfortable bringing this piece of technology in. And the intent would be that you would have either 2 individuals or 2 teams for this risk assessment. So one would be collecting all of this data, identifying what those potential risks are if we bring them into our product, and then proposing potential mitigations for those risks. And then there would be an approvers team who would essentially review all the information and make that decision, yes, we as a company are willing to accept these risks and build this into our product, or no, we need to look at an alternative solution. So those are some areas on the design and development side. Tim also talked about the manufacturing and logistics management, and for this, it's really important that you have a strong supply chain risk management plan in place for your company. The National Insider Threat Center at Carnegie Mellon University found that over 15% of insider threat incidents are typically coming from an organization's supply chain from their 3rd, 4th tiers down. So it is certainly a risk across the board. And with this risk supply chain plan, you want to do a thorough vetting. I think Brad mentioned an approved vendor list. SafeNet AT has one as well. You want to do a thorough vetting of each of your contract manufacturers. You want to understand what testing and analysis are they doing of their suppliers to ensure we have component traceability and reducing any counterfeit part chances. You want to see what random testing, both functional, stress, and beyond that they're doing. What tamper-proof measures are they putting in place for shipping their products for final delivery? So there's a whole host of things that can be checked, and that's just a small subset. But even if organizations aren't required to have this type of plan in place, in terms of starting with something, there are a lot of policies out there. The ISO 28001, a lot of the NIST standards out there, they have a set of guidelines that you can use as a starting point for building up your supply chain risk management plan. And the last thing I just wanted to note is the Department of Energy Cyber Conference is actually going on this week in Denver in parallel. And just yesterday, Steve Black, who is the Director of Intelligence and Counterintelligence for DOE, was doing the keynote speech on supply chain. And his final point was, you need to know your suppliers and where your hardware and software is coming from, because it does matter. And supply chain risk is becoming the #1 target. So that is it for me.
All right. Thank you, Jody. For our final panelist, I would like to welcome Mr. Fred Renovar. He's currently the Chief for DISA Mission Assurance and DISA DODIN Critical Infrastructure Protection Program, SIP, Cyber Operations Directorate, Defense Information Systems Agency at Fort George G. Meade in Maryland. Among his many roles and responsibilities, he's the lead for the SIP program, reporting to OSD Mission Assurance. He's the technical advisor on matters involving ongoing programs and organizational structures, evaluating deliberate and contingency plans and policies for use by the Department of Defense employees in the development of information technology criteria and mission assurance programs and plans. He's the lead for the agency's combat support feasibility planning, providing managerial and supervisory oversight to the DISA supplemental requirements in support of the operations Inherent Resolve, Freedom Sentinel, and other contingency operations in the global war on terrorism. Mr. Renovar is subject matter expert for critical information infrastructure protection for the Department of Defense, providing his expertise to the National Security Council, the DoD CIO, OSD Policy, and OSD Cyber. Mr. Renovar also provides strategic planning for agency participation in annual COCOM Tier 1 level exercises, as well as spearheading initiatives to implement standards, methodologies, and strategies that ensure the agency's mission of providing world-class service to the warfighter. Mr. Renovart?
Is it on? Okay. Lisa, boy, you make me sound awful good. I'm not so sure about all that stuff you're saying. So thank you guys very much for coming today. I'm a little bit different. I'm a country boy. I haven't changed too much in the last 40 years. That's how long I've been in this telecom business. We're coming up on a pretty big anniversary in July. First of all, who in this room has a smartphone? Anybody? Oh, come on, raise your hands. Everybody's got a smartphone, right? The technology that you have in that smartphone is more advanced than the supercomputers that NASA used 50 years ago to put a man on the moon. Think about that for a minute. Think about the evolution of technology in 50 years. Actually, just think about the evolution of technology in the last 10 years. Think where we're going to be 10, 20 years from now. We are limited right now with air combat by a pilot sitting behind a plane being able to pull how many G's before his body basically shuts down and he passes out. 10, 15, 20 years from now, we're not going to have that limitation, right? So the planes are going to be unmanned, piloted, fighter planes going uber super fast. That's my technological term for that, uber super fast. So that's changed. So before I get started, I always give a quote from an old dude. And when I get done, I give another quote from an old dude, two different old dudes today. So the first one, victorious warriors win first and then go to war, while defeated warriors go to war first and then seek to win. So that was a famous advisor to a general officer that lived over 2,000 years ago named Sun Tzu, right? So where are we at today in this evolution of technology and capability with our adversaries, right? The people that really don't want democracy on this planet to be spread. Where are we at with our adversaries and their ability to influence our day-to-day operations based on getting inside of technology? You know everybody that raised your hand, how many of those phones were made in America? Anybody get a phone made in America? Wait, let me think about this for a minute. How many of those phones that have a rare earth metal in them, did that metal come from the United States of America? So whether you like the POTUS or whether you don't like the POTUS, a lot of the things that he says is absolutely correct. We've outsourced so much of our capabilities that it's not being developed in this country anymore, right? So my job at DISA, I'm the Chief of Mission Assurance. So I basically have to know all the contingency and operational plans the DoD has, whether it's humanitarian disaster relief efforts, or whether it's direct combat operations in Afghanistan, or everything in between. DISA is the big bandwidth telecommunications service provider for DoD. We do not manufacture any equipment at DISA, despite what everybody thinks. We don't have a factory on the back of Fort Meade where we're manufacturing stuff. We rely on industry. Right, so my industry partners that are here today, SafeNet and Juniper, I got to tell you, we rely very heavily on your equipment. We rely very heavily on what you're doing as far as supply chain risk management. Right, so if you look at the national pillars for cybersecurity, and if you look at some of the things that we're concerned about, controlling that supply chain is really important to us. But I can't control anything that's happening inside of their factory. I can't control how they're managing their subcontractors. But I have to rely on them, right? You know, we live in a funny world today. 40 years ago when I entered this business, and over 40 years ago when I entered the military, there were specific vendors that operated in this space. If you were in Germany, it was Deutsche Telekom. If you were in America, it was Bell, right? That's changed. We deregulated that stuff. There's vendors today operating in this battle space or in this capability, technology, advanced battle space, that didn't exist 10 years ago. Or if they did exist, they weren't considered very strategically important. In DISA, we rely on our program managers to take a proactive approach to how they manage their supply chain portfolio. If they're going to put Juniper or Cisco or SafeNet or whatever, or Motorola, whatever it might be on our network, we're relying on them to make sure that those are approved vendors on the approved product list and their capabilities meet our supply chain rigor so that we can do a proper risk management executive decision. We also rely very heavily on our partners within DoD, whether it's the intelligence community or whether it's DHS. They're not DoD, but they're kind of this whole government deal that we're all part of. We rely on them as well. So it's kind of like a teamwork. It's kind of like being on a football team, right? You guys part of the football team? I was at one point in my life. I was the water boy, and I kept spilling the thing. I'm lucky they didn't yank me off the field, but the coach was generous. But all that being said, this is a team effort. So, as we look at this stuff, as we talk about supply chain risk, as we talk about how do we get at this, how does DISA get at this? Well, I'll tell you, DISA is not going to get at this with 3 or 4 people looking at supply chain risk. It's impossible. And it's really impossible when you got a guy like me that can't even spell it most of the time. So that's why we rely so heavily on industry. That's why we rely so heavily on the intelligence community and with our partners within the government, both DoD and the federal government. A quote was said to me many, many years ago, and it took me a lot of years to figure out they were probably talking about me. But the quote went something like, "It takes a village to raise an idiot." Well, I was probably the idiot that the village was trying to raise, but the reality, it takes a village to get at supply chain risk management. How we get at supply chain risk management is through teamwork. We have trusted employees, we have vetted employees, we have trusted vendors and vetted vendors, and then through that, we have to have proper control measures in place. And we rely very heavily on industry to give us this. So I'm going to turn it over to you. I know it went kind of quick today, Lisa. I'm going to leave a little time for questions. Hopefully they don't come to me and they come to Brad and Jody and Tim. So back to you.
Okay. Thank you, Mr. Renovar. All right, I'm going to start us out with a question, and then we'll open it up, and you can come up to the microphone and ask your question. And we'll have about 10 minutes to do questions. All right. First question is, how long do you think it will take for the government to actually enforce the new strategy and the resolution of supply chain security from other countries?
What are you guys looking at me?
I think my number would be 10 to 15 years, and I realize that's a pretty pessimistic number. I'm a pessimistic guy because I work in the security space, but yeah, I think it's going to take at least that long.
All right. Anybody else?
Yeah, I think it's going to take several years. I think some of the components that were in those pillars are around identifying roles and responsibilities. I think that can be done sooner rather than later. But some of the things like developing a really solid incident response plan and how to address it, I think that's going to take a much longer amount of time.
Yes, agreed.
Well, and I would just say, there are numerous agencies that have implemented a review of supply chain risk management for their vendors. Some agencies are ahead of others. DHS has launched their supply chain risk management task force really to inform the government on those components that they should be looking at when they select a supplier for their best practices in this area. So they're evolving. I don't know that it's going to, things are progressing, and in some areas they're progressing more rapidly than others. So I don't know if it's going to be 10 years. I don't know that it'll ever be fully implemented because supply chains change over time. In the 80s, most of our companies operated our own factories, and then since then it's all been outsourced. In the next 10, 15 years, supply chains are going to change remarkably again. And so what we have to do is always keep our eye on the ball to make sure that we're looking at where the risks are in the supply chain and taking those mitigation strategies to make it better.
First of all, I'm going to say I didn't stop my coat with an old dude, so I'll do that at the end of this one. You can't go on a football field without having a plan. So the first thing is we've got a plan in place, right? A strategy leads to a plan, development of capabilities. You can't boil the ocean. I know that's a cliche that's been used many times. But, Frederick the Great once said, "Those that protect everything protect nothing." I think this raises the framework for starting to look at, from an industry perspective, on what are those most critical, important things that we have to get at today that we can't live without. I also think that should help prioritize how we move forward with looking at that. From the business that I'm in, capacity and diversity equals survivability. And the diversity is not just a fiber path and how it's routed, it is also what kind of equipment you use, who your employees are, who your trusted vendors are, those things, right? So you have to kind of develop a whole portfolio. Getting this strategy gets to that, and it delivers a framework that we can work off of in the future.
Yeah, it's a very important topic, and I know a lot of people are working on their supply chain risk management plans. I know that's going to be a big thing that's going to be important this year as companies, both suppliers, both manufacturers, both resellers, are going to have those plans in place. Any questions from the audience? All right, I'll do another. What is your company doing to stop or prevent insider threat at each point along the supply chain? I know Jody spoke quite a lot about insider threats. Anyone else want to take that?
Well, yeah, so from an insider threat perspective, that can be internal employees, it can be supplier employees. I think what we look to do up front is to really vet out those people that we're doing business with, or vet out our own employees. But there's also a level of paying attention to what's going on both in your network, in the development environment, and in the supply chain. And so, it starts with hiring and doing business with people that you can trust, and that has to do with making sure you're doing a good job vetting them out. But then it's also about looking at and understanding how might somebody take advantage of your products or infiltrate your products and take steps to eliminate those threats, either through monitoring, through testing, through pen testing, and other mechanisms. So, insider threat is a huge deal. People talk about, there was some mention about, is this stuff built in the United States? Foxconn recently announced that they're going to build a mega factory in Michigan, but they can't find enough employees to staff the facility, so they're going to import 50% of the employees from China. So, our philosophy is it's about how we build our products, not about where we build our products, because the threats exist both in the U.S. as well as outside the U.S. And having a good, solid insider threat program is critically important.
Yeah, so, I kind of come from the consultancy background, right? So when we talk to customers about how to deal with that, I think our first step is awareness, trying to understand as much about their processes as we can and understand as much about the activities that people take in a day as they can. I think having good awareness, from a network and technology perspective is very critically important. The other thing I try to do, and we do this a lot, is, penetration tests or red teaming exercises, where we'll try to go in and break into a facility and, put an implant on the network and things like that. And that helps expose a lot more of the insider threats than you might anticipate, because once the company sees that those things are possible, they start thinking about their whole process of insider threats. So I think for us, the way to evolve it is to show people what could happen if there was a malicious individual in there. And again, we talk about insider threats, and you mentioned it, I think. Not all of that is malicious. Some of that's innocent people that are trying to be loyal, trying to be responsible, and they just make a mistake. So It's also security training for all employees and contractors, just making sure everybody's got a good sense of risk awareness.
Yeah, so I'm going to pivot on that. So I actually think it goes back to training, right? So in most cases, you actually have rules and regulations and procedures in place, and sometimes it's making sure that people are trained and then they're held accountable to follow that. Yeah. Every single one of the exfiltrations that we've had of information as far as somebody doing espionage against the United States, there's a clear set of indicators that somebody was doing something wrong, right? And sometimes people just were not paying attention. But if you continually reinforce that, continue to train them, at least you're addressing that if there is somebody that's doing something malicious, you can possibly catch it if you're keeping your eyes open based on what you're supposed to be doing because you're trained in it.
Exactly.
And then if it's somebody doing something wrong, again, they need to be trained, but then the other people that are around them need to know, well, that's not standard operating procedure, then you're going to cause damage and harm to our systems and our capabilities.
Yes. Those are all fantastic points. Thank you, guys. So I'd like to thank our panelists, Brad Minnis, Jody Schatz, Tim Brown, and Mr. Renovard. Thank you very much. I wanted to thank you for coming to the panel. The panel will be available for a few questions as we move towards the luncheon. Certainly don't want to be late for that. Also in your chairs, you should have found a card that has a follow-up webinar that we'll be hosting. We'll have additional information, and this same panel will be participating in the June webinar. So we'd love to have you join. If you didn't get one of those cards, we'll see Joe DeFranco. He's going to raise his hand. If you need a card, to have that web address so you can register for the webinar. One more piece of housekeeping is make sure you get your badge scanned if you would like a continuing education credit for this and have a record of your attendance. If you don't get your badge scanned at the end of this session, you won't be able to get credit for it. Thank you so much for joining us.
Tim, thanks. Good stuff.
Thank you, Fred.
Jody,
Appreciate it.
thank you.